Hello, I am Jasmine Batra. I will be explaining question 2 of homework 11 from probability and stochastic process. In this question, it is suggested that the following function of v that is a part f of v is equal to e power minus mod v, and for b part f of v is equal to sine square v by v square. C f of v is equal to 1 to 0, that is mod of v less than equal to alpha and mod of v greater than alpha. And this graph may represents an autocorrelation function of WSSS stochastic process by setting v is equal to tau, or spectral density function by setting v is equal to omega, or both, which functions f of v may represent either or both. Explain your answers. So R of z is an autocorrelation function of a real WSS solution process x of t, and then it is even R of z less than equal to R of omega, and its Fourier transform is non-negative if S of omega is a power spectrum of a WSS process x of t, then it is non-negative. So f of v is equal to e power minus v. It may represent an autocorrelation function because e power minus v is even, and e power mod v less than equal to e power minus 0, and e power minus v, which is 2 alpha by alpha square plus omega square, which is non-negative. It may represent a power spectrum also because e power minus omega greater than 0. So for the b part, f of v is equal to sine square v by v square. It may represent an autocorrelation function, that is sine square by tau by tau square is even, and sine square tau by tau square less than equal to limit that tau tends to infinity. Sine square tau by tau square is equal to 1, and sine square tau by tau square gives this graph, that is which is non-negative. And for the second part, it may represent a power spectrum also because sine square omega by omega square greater than 0. C part, f of v, which is from interval 1 to 0, mod of v less than equal to alpha, mod of v greater than alpha. For this graph, it cannot represent an autocorrelation function. Its Fourier transform is 2 sine alpha omega by omega, which is not non-negative. And for b, it may represent a power spectrum also because f of omega greater than equal to 0. Hence, we have proved which of the function that f of v may either represent both. So, thank you.